Okay, so very quickly, I'm just going to run through what was covered last lesson. Okay, and then I will go into the focus for today. Now, so last lesson we talked about, what is science, okay? And then very simply, we know that actually it's just studying of, everything around us, how come certain things happen in certain way, etc. All right, so attitudes in science is very important. Okay, so you want to be a good scientist, you want to be a good science student, you have to possess this kind of attitudes. Yeah, so this is just a very short list. There are many, many other attitudes you can actually find easily when you Google. Yep, attitudes in science. So curiosity, objectivity, perseverance, open-mindedness, integrity, all these are important. So I think your teacher already started going through this. Am I right? If yes, just raise your hand. Your teacher went through all this with you? Not yet. Are y'all doing chapter 1 now? Okay, so what are y'all doing at the moment, Sharon?
Me? Oh,
Yeah.
this is my first trial.
How
So I
about
haven't done
in school?
at school, like my school.
Yes.
Yeah, they don't usually teach about these rules. We're actually at chemistry right now. They don't usually do the introduction. They just went straight to the lessons. Yeah.
I see. Okay, this is actually part of chapter 1. What school are you in? Do you mind typing in? Yeah, you type it in. Okay, Evan, you are doing scientific endeavors or not? Chapter 1 of the textbook. Sharing chemistry is also my favorite. Actually, I'm trained in chemistry.
Miss, actually, I'm not in Singapore lah. I'm not in Singapore school. So
I
like,
see. Okay.
yeah, that's why I'm a bit confused.
Okay. Anyway, this is your trial lesson. So you try out today's class, see whether it's suitable because the curriculum is very different. Yeah, we have students who came in for trial from Japan, from different parts of the world. Okay, so they found out about AD tuition, they got interested. So they came in and then somehow some of them felt that it was very different. So they wanted something more beneficial to their learning in school. So that's why they chose to, attend maybe tuition centers in their own country. So never mind, you try it out and see whether this is something that can interest you lah. Okay? Yeah. So no worries.
Okay.
Evan, what school are you in, Evan? You want to type it in? Because actually Heidi is in a IP school doing the IP curriculum, right, Heidi? Correct or not? Yeah. So Heidi is also here. I have IP students in my Sec 2 classes also. So yep, they still continue even, after Sec 1, they continue in Sec 2 now. Yeah. So yes, okay, thank you. They find that it's still relevant and beneficial, but for Sharon's case, it's a special case here because she's from overseas. Now, Alec just told me that he's actually still in P6, but he's attending the Sec 1 lessons. Wonderful, Alec. How come you choose to come here? You are not learning something that's relevant to PSLE, no? It's okay with you, is it? Yeah, okay. That's good. So long as your mom knows. Okay. Now, Evan, I know there are some schools that skip these chapters, but you just bear with me. Okay, these are actually quite logical stuff, very simple stuff. Not many of these are actually tested. Okay, not many of these are actually tested. All right, but you still need to go through this because, all right, the science syllabus is designed in such a way that we need to cover all the way from chapter 1 to chapter 16 for lower secondary. Yeah. So scientific method, okay, this is something common. Okay, it doesn't matter where you are. All right. It doesn't matter whether you're in Singapore, or in any other country. Scientific method is actually carried out by all scientists. Okay, so you need to have certain process skills in place. Okay, so if you were to read all these, identifying certain problems by making observation, you need this skill called observing. So you have to be observant. Okay, then suggest a hypothesis. So you come up with a possible explanation for the observation. Then you test out whether your hypothesis is correct. Okay, so the process skills involved: inferring, predicting. Okay, so I'm not going to go through step by step, because I think in primary school, you also covered some parts here already. Okay, if you recall, your teacher must have gone through this when you were in primary school. So testing out the hypotheses, then after that, you gather your data, you look at your results, right? Interpret from your results whether you have, whether you have already got a valid hypothesis, or do you need to change a new one? Yep, so you come up with a new hypothesis, then you run through the whole experiment once more to test out whether your new hypothesis is valid. Can? So if let's say your hypothesis is valid, you have already formed a new theory. Okay, right. So we have gone through these last lesson as well. Independent variable, dependent variable, controlled variable. This is what you have in primary school also, but you don't use these same terms. So you would have seen independent variable is actually the change variable, something that you are in control of. Okay, you can manipulate that. After that, you need to measure, right? Measure certain things. Like sometimes it's temperature, sometimes it's amount of the gas, sometimes it's mass. That will be the dependent variable, something that you are measuring. Okay. And then after that, things that remain constant. Now, to have a fair experiment, you only change whatever variable that you are going to explore. That's the independent variable, right? Everything else stays the same, right? Then we also have gone through this: benefits, abuses, limitations of science. So what's the benefit? You can see all these are invention, discovery, helping us to breed maybe better chicken, etc., make the chicken grow big faster, discover new medicines to help us recover from a certain illness. Abuses of science. Okay, anything that is good can also be bad if we don't use them the right way. For example, abuse of medicine. Okay, Panadol is actually paracetamol. You take that to maybe get rid of headache, get rid of pain, for your fever. There are people who abuse this paracetamol. Okay, they take certain amount, they mix it with something else, and then it becomes a drug to get them to feel high. Okay, so they feel very good about themselves. They feel like they're floating. So this is called abuse of science. Invention of harmful weapons, pollution to environment, these are all the examples. Now, limitations of science. Science cannot do everything. Like it cannot solve emotional problems. It cannot prevent death. It may prolong life, but it cannot prevent death. Okay, so your sickness, you can be cured of the sickness, so you don't, die due to that particular sickness, but you can still die of old age. So it cannot prevent death. Science also cannot cure certain viruses or diseases. Okay, maybe they can help you to, stay okay for a longer period, but the virus, or the sickness is still in you. Now we look into the measurements. We talk about parallax error, zero error. Okay, so parallax error is how you position your eye to do certain reading. I think Sharon will agree when you do chemistry, right? A lot of these measurements, like volume of liquid, how much liquid there is. In physics, you will also do a lot of measurements. Okay, where you position your eye is extremely important. Okay, I don't exactly know which level of chemistry that you're doing, because not too sure about the curriculum overseas. Yeah, but I am a chemistry major. I was a chemistry major. I taught chemistry in secondary school as well. Okay, so maybe I share my experience. I taught for 20 years in schools. Yeah, so both secondary and primary. Most of the years are in secondary school. So when you talk about chemistry, wow, when I look at it, I'm like, wow, that is my favorite subject. Okay, welcome to my world. It's fun.
Nice to meet you.
Yeah. Okay, now, so zero error, like when you're measuring mass using this electronic balance, when you're measuring length using the digital caliper, you will need to make sure you have these tear function to help you get back to zero reading. Okay, so this will be practiced in the science lab. Your teachers will definitely let you try it out. Okay, then we talk about accuracy and precision. This is something that maybe your school discussed with you already. Evan, have you done this part? Or it's very different? Haven't done this yet. Okay. Now, what's the meaning of accuracy? What's the meaning of precision? They actually are not the same thing. All right. You can be accurate, okay, and precise, but you can be precise without being accurate also, you know. Okay, so what is the meaning of accurate and what's the meaning of being precise? Maybe I will share an example. If you have, done this archery before, this particular activity, the bow and the arrow, you have to shoot certain target, right? So let's say when I hit the bull's eyes, yeah, I'm considered to be accurate, isn't it? Yeah, because I hit what I want to achieve. Okay, I managed to get the bull's eyes maybe 3 times, 4 times. Then I can say that I am accurate and precise. Okay, but if I don't hit the bull's eyes, there are a lot of rings, right? Outside the bull's eyes. Maybe I hit the third ring. Yeah, the third ring. And I hit similar position 5 times. So I am extremely precise, but I'm not accurate. Okay, so that is the meaning. Accurate means you really hit your target or you reach the answer that you want. Very close to your answer also can. Okay, but being precise means maybe you are always consistently getting the wrong reading, but your wrong reading is very close to each other. All right, so you're precise, but you're not accurate. Okay, so that's the meaning. So lab rules, we have gone through. Now, chemistry lab definitely must follow the whole set of rules very strictly because you're dealing with chemicals. It's very, very dangerous and can be harmful to you. Okay, so the rest of you, if you've gone to the science lab, I'm very sure your teacher would have gone through all these, maybe even show you certain videos. Yeah, and then I remember back in my time when I was teaching in the school, I also make students sign. Okay, after they have gone through all the lab rules, right? They are supposed to sign against all these things that we've gone through. They are supposed to tick the checkbox. After the teacher cleared with them, right? They have to complete the checklist and then they sign at the bottom. Why? Because I want them to remember they have already agreed. They cannot do this, cannot do that, cannot do this, cannot do that, or must practice this and that. So if they break the rules, I have something to show them. Look, you already signed, right? Okay, this is our contract. You have to behave in the science lab. Because if you don't, somebody's life can be in danger. If it's not yourself, it could be your lab partner. It could be myself, the teacher, or somebody else. Okay? Now, so all these are important. You need to follow. Yep, all the lab rules. Okay, don'ts are here, like don't run around, don't throw chemicals into the sink, then don't play in the lab, don't eat in the lab, don't drink in the lab, don't touch, taste, or smell any chemicals unless your teacher asks you to do it. Yeah, and you are not supposed to bring anything out of the lab. Okay? This kind of hazard symbols, you find them on bottles, yeah, on certain boxes as well. So what do they mean? These are important. Why? Because it is not just used in our school science lab. In the industries, you also see these symbols very frequently, sometimes even in hospital. Okay, later on, you will see one symbol that is commonly seen in the hospital. Now, this first symbol here shows that, the substance in that particular container is explosive. Yeah, it can be It can be dynamite. It can be,